So, thanks for being here, guys. My name is Pedro Pessoa. I'm from Server Density. We started using Puppet a little over a year ago, so this is a very introduction to some of the stuff that we are doing. Even myself, I'm quite new to Puppet, so I've been using it for less than a year. So this is to share with you guys some of the stuff that we've been doing. I'm going to show you some examples of what we did, and then you can tell me if it's any good or not. Okay, just to tell you what Server Density is, it's a monitoring service that you can use to tell if your websites are slow or down, and then you can dig into your servers and see the metrics that we collect for them. So basically, we collect a lot of data for all the servers and all the services that our customers have with us. So, and we collect a lot of data, and we have to be fast in retrieving that amount of data also. We run about 100 servers for this, all through Puppet configuration. So this is how our farm looks like. It's pretty straightforward thing. The MongoDB cluster is the biggest set of servers that we have, and I'm going to talk a little bit more in depth about the load balancer because we did some interesting stuff there. Just to give you some initial information about it, we run our load balancers behind a feature that our hosting provider, which is SoftLayer, gives us, which is a global IP, and we can point that global IP to any server on our infrastructure. With this, we can make effective high availability with some load balancers. In this case, there are 5. We run 2 load balancers per data center, and we can switch using this global IP feature to any of those. And I'll be showing how we do that with Puppet. Starting here. So we use Puppet Enterprise. What you see here is a snippet of the UI. And for these global IPs, we have 2 of them, one for each data center, and we want to make our load balancers aware of these global IPs, so that when a request comes in for any of the IPs that we have, any load balancer can answer them. And we don't want to manage the complete configuration of the load balancers for this, because it's 2 times 2 services, so two times per IP, one for HTTP, one for HTTPS. It's a big configuration, so we do it using Puppet. We actually have to take this string. It's only a string on Puppet Enterprise UI, and we split it on the manifest. Then it gives us an access to an array where we can later on the pound configuration, which is the load balancer we are using, we can then iterate through it and expand to the actual configuration. So this is just a snippet. There's a lot more than this. Basically, this is an HTTP listener for the load balancer, where we take a value from the array and then generate the listening address and some other configuration that I'm not showing here. This is an interesting way of reducing the configuration that we actually manage, because this 150-line template, something like that, will later on be transformed in several hundred line configuration file, which we never look directly, which is good. Okay, so this is for the load balancer configuration. I'm going to give you another example. What we use it for Apache configuration. So this is basically what you would find on an Apache configuration file. I'm not going through all of them. I'm just going to notice a couple of them. So you see, besides the Apache configuration, there's also an agent key for our own monitoring. We monitor our own stuff using our service. And later on, these configurations that we put on the Puppet Enterprise UI on a group, which is our own web application group, gets replicated to all the Apache servers on the web cluster that we have. This is done through a manifest file. Here you can see a piece of it where we get the site domain variable from that configuration, and this gets translated into a vhosts configuration file through templating again. So picking up the previous definitions that we had, and again all the servers in the Apache cluster, in the web cluster, pick up the same configurations, and we will be able to see the same Apache configuration on all web hosts at the same time. There's even an additional configuration that was not present on the screen capture, which our developers use for debugging. So whenever they need to debug some customer request or something like that, they log on to the Puppet console. They turn on debugging, additional Apache debugging, simply by defining this variable at the Puppet console. I'm going to show later on a different usage of the Puppet Enterprise console for on-call engineers that don't have access to servers, but it's something similar to this. One other use that we make of Puppet is to fine-tune the server templates that we get from our providers. So our main hosting provider is Softlayer. That's where we have most of our servers. Then we have other providers that get the servers to do the worldwide monitoring of your services, so our customer services. What we do with Puppet is fine-tune. This is a simple example. We fine-tune what the provider does in terms of server templates, either dedicated or virtual. So in this case, this manifest gets applied to a group called Softlayer, and it will just remove the packages that we don't need, and we don't want to have packages that we don't need on our servers, because it will give us additional work when considering security updates and so on. And this also gives us another interesting thing, which is with this we get a group where we can see servers that are on different providers. So this was Softlayer, and if I move to the next one, this is Rackspace. So Rackspace provides us with servers for our remote monitoring. And in this case, we have to do something completely different with the Rackspace servers. They are set up to use the UFW, the firewall. So we use Puppet in this case to change the configuration of that firewall to be able to, for the server to be able to access our own infrastructure. Again, we get on Puppet exactly the complete group of servers that are deployed at Rackspace through this grouping. So the manifest itself, there's nothing special about it, so quite straightforward. So it was just an example of what we were doing here. Okay, something regarding SSH. Sorry, one second. The important thing here, for those of you that were in one of the previous sessions, we do use still manifests all bundled together, so we are not separating data yet, which is something that we will want to do soon, so given the benefit. But I wanted to share this manifest with you for two reasons. One of them is that with this we can add or remove users from all servers in some minutes, less than 5 minutes. So it's a matter of changing the manifest, removing the user, and then committing it, doing a Puppet run on all servers. You can trigger that through the live management on Puppet Enterprise. That's what we usually do. And with this, you can add or remove users. If someone leaves the company, you can remove his user from all servers in quite a few minutes. One other thing that I wanted to show you with this manifest is that when we have servers that are directly publicly accessible, we force multi-factor authentication on them by setting up, in this case we use dual security, by setting up the dual security for them. This gets done whenever we apply a configuration opening the SSH port on that server. So if we want to open the SSH port, automatically this configuration will also get included, and we will be forced to define these variables, otherwise the manifest will not run. So this is a way of enforcing some rules when you open up a server, for example, to the internet. Okay, so now for something completely different. This is how we run system updates, so package upgrades, using Puppet and mcollective. It's a way of pushing changes to all your servers. We don't do this for all the infrastructure at once, so we apply a canary approach where we have a subset of servers that are, in fact, are canaries. And for these, we will update all packages. So it's simply running the mcollective and passing on a command. So in this case, it's apt-get this upgrade -y. So we do this on these servers, and before this you could do another command like apt-get update on all of them, or you can even use Puppet Enterprise console for that, because it's available directly from the console. So we do this for this set of servers. We check them out to see if the upgrades were successful, if there is no impact on service. So for example, you can see here one of the web servers. This web server, while doing this upgrade, was removed from rotation on the load balancer. So this is just a warning for the guy doing this to do that. By doing this, we can then access the web server directly and see if something bad happened, and if not, we can proceed the upgrade across the entire infrastructure. And then we have other groups defined in a similar way like this. For example, if we have 3 web servers on the cluster, we will have a group where there's web server 2 and another group where we have web server 3, and we will run these upgrades separately so that at any single point there's only one web server out of rotation from the load balancer. So this allows us to upgrade if everything goes okay, which usually is what happens. If everything goes okay, we can do the full upgrade on about 90-something servers in under 2 hours, something like that. Okay, so the reboot process. So if you do an upgrade and you want to reboot the server, you do a similar command. So you have the group, and then you can reboot them. And if you do an upgrade and you don't exactly know which servers need reboot because you did a full upgrade, and on some servers some packages were upgraded that don't need the machine to be rebooted, and others need to be rebooted. You don't know when you do that, so it's a simple matter. In this case, it's on Ubuntu, but Debian base, I believe it's the same thing. If a package requires reboot, it will create a file on /var/run/reboot required, the reboot required file, and you can use PuppetM Collective to search for this file across your entire infrastructure. And if the file is present on a server, it will output this. For example, on this server, the file was not present. If the file is present, it will output this. So you can, in fact, script what servers you need to reboot. So, and you don't need to reboot all of them. So this was an example of how to use mcollective to do system upgrades and finding out stuff about your entire infrastructure at once. Okay, now for a different topic, we have on-call people that basically get the alerts when something happens. And some actions, they don't have access to the entire infrastructure. They do have access to the Puppet console. And sometimes certain actions might need to be taken, and one of those actions that we have can be done on the Puppet console, and that's what I'm going to show you. We use, besides the load balancers for the external HTTP services, we also use the load balancing on internal services. And all servers share the same hosts file, so they can reach in this case it's the metrics service, they can reach the metrics service at this IP. So this IP gets then introduced into the hosts file through a template that builds up the host file that is then distributed to the complete infrastructure. And since this is defined as a variable and you have access to it from the Puppet console, you can actually edit it. So you don't need to log on to any of the servers. You just use the Puppet console. You edit it on the base class. This is a class that, sorry, the base group. This is a group where all our servers belong to. So in fact, when you are changing it here, you are changing the way that the hosts file is generated, and when you apply it, and then when you trigger a Puppet run on the console, so you can go to live management on the console, select the nodes that you want to apply this run once. You select those nodes. In this case, I'm selecting the nodes that depend on that configuration or that rely on that configuration. And then it's just a matter of clicking run once, and this will trigger a single Puppet run on those nodes. It even outputs the results of that run, and then you can see the log on the console. And this will trigger this configuration to all of those nodes, allowing you to globally change it across the nodes that you selected. Okay, so this is what I wanted to share with you. Questions? Let me just turn on the light. So.
Got a question?
Sure.
What's the advantage of Puppet Enterprise? Like, can you do what you're showing us with the non-enterprise version?
You don't have the control on the non-enterprise. So this that I was showing before, you don't have the console. So this is only available on Puppet Enterprise. Yes.
So how did you start from having no Puppet use development?
Okay. Yeah, that's a good question. So we had the very first version of server density was quickly hacked together, so to serve as a proof of concept, and there we had nothing, and that grew as we got additional customers until the point where we started building the second version, and we were fortunate enough to be able to build the second version on an infrastructure by itself. And this infrastructure was built from scratch using Puppet. It didn't take that long, so we were just building things. So we started with 1 or 2 servers. And this new infrastructure also started small, so we didn't have clusters, but it was prepared to grow. So we did that using Puppet, and then Puppet allowed us, for example, to scale the web servers very easily. So you just spin out a new node, apply to the web server group or add it to the web server group. It will get all the configurations automatically. You go to the load balancer configuration on the console. You add that new server, and that's it. So that's one of the examples. It even paid out when we had to move between hosting provider. So before we were in a hosting provider that only supplied us with virtual instances, and for Mongo and as our data started to grow, for Mongo and certain aspects of Mongo, it's much better to have dedicated servers. So that hosting provider did not allow us to have a mixed environment, so we had to move all our servers at that time, and at that time we had about 60 already, and one guy alone was able to do this in a couple of weeks using Puppet, so it also paid off.
You can handle configuration rollbacks, static and
yeah, so everything that you did not see here on the console, so let me show you a manifest. This is under configuration management. So you can, for example, if I add a user or remove a user, it will be tracked on the configuration management, and this is how we handle these kinds of rollbacks. And on the console, there are no rollbacks. So if I change this IP to something else, so using the GUI, that is not tracked. That is tracked on the console itself. You see that this node was changed, but Puppet console still doesn't have doesn't show you who changed it. It already has user management, but it doesn't show who changed it and what it changed for. I don't know if you were at the previous talk on PuppetDB. Yeah, so there's something we want to get out of the PuppetDB when they have, or when we have a way of knowing which configuration was applied when. Okay, so this is when we get tracking of changes for this. So that's why we don't have all changes available at the Puppet console. For example, the SSH users, we don't have a variable from the console to it. So because we want to track that through configuration management, through the repository changes.
Thank you.
Any further questions? Okay.